Hi, this video we are going to talk about BGP finite state machine. So, BGP follows finite state machine. It uses TCP protocol and it uses TCP port 179. So, let's look into the BGP state machine and the states involved. So, why we actually need to know about these steps? Do we need to memorize it? No. We don't need to memorize these steps, and these steps are only important to learn, to know, to understand so that we can troubleshoot BGP. So, as I said, it's not important to memorize these steps, but it is important to understand them so that whenever you're troubleshooting, you are seeing that BGP is flapping between state, connect, and active, or you are seeing that it goes to the open and then it goes back to idle, or it jumps from established to idle, so you know what wrong could be possible and you can save your time in troubleshooting. So, like OSPF have 7 states. Before it even gets to the final full state, BGP has these states, and the best stage, or the one we like it to have, is established state. So the established state is the final established, is the final running state of the BGP where we find it as a stable. So let's move into all of these one by one, and let's see what it is. So idle state. Idle state is the first stage of this finite state machine. There are 2 possibilities that you will end up at idle state. First is like as soon as you configure the BGP router, obviously it is going to be in idle state. Or in any of the following states, like in open or in established or in active state, you meet across some error. In the case of error, as a result of error, you will fall back to idle state and then start from beginning. So there are 2 possible ways. First is whenever you start configuring, so it will be initially at idle state. It will stay at idle for very small time and then it jump to connect. And the other is like if there is some error in any following state. Okay, so what does the router do at the idle state? So what it does is very simple. It's just send a TCP. It just simply initiates a TCP connection. And then after the idle state, it jumps to connect state. So BGP during the connect state, actually it has already sent a TCP request and now it is waiting for the TCP connection to be completed. Once successful, it jumps to the open state. So let's say once it starts the TCP negotiation, the TCP is successful, it goes to open sent, and if it is unsuccessful, then it actually jumps back to the active state. So when it's successful, it goes to open. It's unsuccessful, it goes to active. Simple. So what happens in active state? So the active state is like once the TCP connection is initiated, it waits for the TCP to be established. So if TCP is not establishing, it goes to active. It is going to wait at the active state for 120 seconds. It's hard coded. It will be waiting for 120 seconds at active for sure. We cannot change it. So it is going to wait in the active state for 120 seconds. The name seems to be active, but there is no activity going on. So it's just the BGP active state where it is going to wait for 120 seconds and then it is going to go back to the connect. So what's the 120 second? It's known as connect retry timer. So connect retry timeout is of 120 seconds. It is going to wait over there for 120 seconds. So if the connect retry timer expires, it goes to the connect state. If during this time it actually like the TCP is established, if during this time the TCP is established, it jumps to the open sent state. So why now the question arises, what could be the problem why it is jumping from active to connect? what could be the possibility that TCP is not establishing. So it could be like TCP retransmission issue, or it could be like TCP protocol has been blocked, or most likely the port number 179 is blocked. So we can look for the interface which is being used to go to the destination, which is used to go to the neighbor, and see if there is some ACL or filter configured on that interface, or maybe in between there can be a firewall. So it could be possible that due to the firewall, it's being blocked over there. So we have to troubleshoot the neighbor reachability issue. After the active state, once we go to the open, so let's first talk about open. What is the open? So open message is basically a message which contains the AS number of the configured in the router, the version, the BGP version, hold down time, and the BGP ID. So these four messages are configured in open message. So these four together is known as open. So what it is AS number, it is the version, BGP version, and then it is the hold timer, okay, and then after hold time, it's the BGP ID. So these four things together makes up our open message. Okay, so at the open send state, the BGP compares the AS number to the AS number of the neighboring device. So for example, if the AS number is same, it's iBGP protocol. If the AS number is different, is eBGP protocol. So let's say if the BGP router is expecting an iBGP and it sees a different AS number over there, so the router is expecting an iBGP session, so the AS number should be same, but we get a different AS number, so it will raise an error notification and go back to the idle state. Then the next thing which we come is the open receive. So once the open message is sent, it goes to the open sent state. Once it's received the open message and all the parameters of the OS message is matched, then it waits for the keep alive message. Once it gets the keep alive message, it will proceed to the established state. When it will get the keep alive message, usually the keep alive message will only come when both the routers, the neighbor and the local router, both of them have all their attributes like in the open message, like AS number, version, and hold timers and ID, all of these are matching up. Then it goes to, it will send the keep alive and jump to the final stage, which is the established state. So let's look into the established stage now. So this is the state which we all want our BGP neighbor to always remain at. Okay, so what happens during this state? Only two things will be going to happen. Update messages are sent and keep alive messages are sent. So if there is any error in this state, like there is some error due to some reason, like keep alive not coming up, then it goes back to idle. So at any state we have a problem, it goes back to idle. What is there is like keep alive messages are generally sent after 6 seconds by default, and the hold down timer, the timeout is 180 seconds. So this can be reconfigured, like some people can drop it to 45 seconds or 30 seconds, depends upon their neighbor relationship. People even configure BFD with it. Okay, so we will talk about BFD and different timers in next slides somewhere else. So let's have a quick review of the BGP state machine that we have been talking about. So the first initial state, we have the idle state, and then we go back to the connect state, waiting for the TCP to be established, then goes to the open send. Open send is the state when the open message is already sent. The open message has 4 parameters. These 4 parameters are matched with the neighbor. We have the open confirm. Once we have the keep alive, we go to the established. This is the common area where we have often routers stuck when there is like some IP reachability issue, we can't reach the neighbor, or the TCP port is blocked, some issue happens, then we are actually going flapping between connect and active state, connect and active state. So this connect and active state flapping, the connect retry timeout is 120 second. We cannot change it, and there is no need to change it either. So whenever there is an error, like established stage has an error, open confirm or open sends, any sort of error comes up, it goes back to the idle state and then starts from the beginning. So what's next? Like the BGP pair is established now. Okay, the BGP pair is established. Then there are going to have two types of stubs going on. One is the keep alive messages being exchanged and update messages are being exchanged. So what is keep alive? Keep alive is, as we know, other protocols also have hello messages. So it's just like a keep alive telling that, hey, I am alive. Then what's next? The update messages. Update messages are important. The update messages are like of different types. Like it can be a withdraw message. Let's say we are advertising some prefixes to our neighbor. We have no longer reachability to those prefixes. So we are going to send a volunteer message to our neighbor saying that, hey, please remove these routes from your routing table. We no longer have access to these prefixes, so remove them out. So this is known as withdraw message, withdraw route. Then we have next layer reachability information. These are the routes prefixes where we can reach, and the path attributes. We have lots of path attributes. We have dedicated slides for it. We will talk about it in detail. So the path attributes, network layer reachability information, and withdraw routes, these are the information which are carried in the update messages and sent to the neighbor. So this is all what we have to talk about in this BGP state machine. Hope to see you in the next slides, and thanks for viewing.